Okay, so let's just talk through this. This is the drive for the ALT full scale build. And what you're looking at the moment is the collet. The collet actually fits on the main motor. So at the heart of each of the drives is one of these babies. These are the E90 scooter motors that we tend to use I tend to use in a lot of the builds, to be fair. Really good 100 watt, solid, powerful 12 volt motors. You can get them in 24 volts. Both will work in this particular build. So what we're going to talk through first is doing the planetary gearbox. And the first bit really is take your collet there. And what we've got a drive gear. So the drive gear literally bolts onto the collet. Now, just looking at that drive gear, what you've also got, you'll see, is a hole through the centre that comes through to here. That enables you to put in an M3 screw, which again, if you look at the length, is about 20 millimeters. So you can actually drop in a 20 millimeter screw that will self-tap an M3 countersunk screw it self-tap through. All it does really is, because the layers are printed this way, it just holds layers together, makes it a little bit stronger. Once you've done that, then you take your collet, you pop your collet on, and you'll see there is 4 screw holes. All of those will self-tap. Lengthwise, if we just have a quick look at the distance between there and there, you're looking at around about 10 mil. So any 10 mil M3 10 mil bolts will quite happily hold that in. Now on 2 of those there is slots for the square M3 nuts, and the other 2 just self-tap, so it goes into plastic and it is pretty strong. On all the gears on this one, I would go for lots and lots of outer layers, so maybe 7 or 8 outer layers, or 9 outer layers. Keep going up, and PET G. You want the gears to be as strong as possible. If you want to start to use more interesting materials, you can try some of the nylons or some of that Ninja Tech Armadillo, which is one of my favourites for gears, but PET G will actually work with this. So assemble that gear first of all, put that to one side. Once you've done that, what we're going to work on then is this main gear hub. Okay, so you'll print out a gear hub which will look something like this. Now when you start to put this together and you start to look at the planetary gearbox, you may think it feels a little bit, or it looks a little bit, it doesn't look like it's going to carry the weight. Don't worry about that. I'll talk about how the stresses actually work later on in the video. These gears each take the little 3mm bearings. These are, as you can see, they're 7mm diameter, 3mm deep, and they've got a 3mm hole in the centre. Again, I use these on the babies and all sorts, and you've got one on either side. Now, you've seen on many of them, if you've built these before, what I tend to have is a little thin layer that you just got to put a screwdriver through, and that's really just to stop me having to put supports in there, so it just bridges across. We'll print these 3 out, pop 3 gears either side, and then once you've done that, what you can do is you basically take a M3 washer, you put the gear onto the washer, you take another washer on the outside, and then you pop a a M3 standard bolt straight the way through that. And again, you're probably looking about 20mm, which would cover that. So an M3 20 self-tapper screw in these 3 here, and you kind of want the screw, the M3 bolt to come level with the outside of there. And again, similar thing with all of these parts, lots and lots and lots of outer layers. So what you'll end up with is this assembly with these gears that will kind of, all 3 of them will spin freely. Now the way the planetary gearbox actually works is if you take the drive gear, it sits in the middle of those. So that drive gear you just assembled will fit in there and it will spin round. So that's the start of that. Then what you want to do is take one of these bearings, and these are 25 by 37 by 7. So they're actually the 25mm diameter, which is this bit here, the 37mm on the outside, and the 7mm deep. So we'll just have a look at them. So all you do is grab the bearing, pop it onto there, so you make that assembly. And then what you can do is you can start to take the casing cover, and what you should then see, and if I just remove that gearing hub you can probably see it clearer, is the bearing will fit into that casing hub quite comfortably, and it will stick through on the other side open. Okay, so this is the beginning of your planetary gearbox cover. The next thing you want to then add is there's another casing plate that sits on the outside of that, and this literally just rests on top at this stage, so don't worry too much. As long as it fits on and it all lines up like that, it's fine. Pop it on there, and then grab yourself another one of them bearings, and that should just fit into there as well. And what that does, if you look on there, is this plate here kind of holds that bearing in place like so, and then the bolts will hold it all together as an assembly. So at this stage, you've literally just pushed it through, the bearings on there, and then the final thing really which kind of holds all this together is this big gear. So similar to the other gears, this big gear has a bolt right the way through, which you can put through if you want to for additional strength. So if I just have a quick look at this gear, I'll just move it across so you can see the back of it. There we go. Okay, so what you've got on this gear is, if you want to, you can put a bolt through there. It's the M3 standard self tappers, and lengthwise, what's that there? It's about 25 mil, so you can put a 25mm bolt through there. It just adds to the strength, but this is a pretty strong part anyway. So what you want to do is pop that onto there, and then through the back here you've got, again, similar sort of thing, two big long bolts that will go through, and they are that hole there is 60mm. I use 50mm on mine, so I put two 50mm bolts right the way through, and they self-tap quite nicely into there. When you're self-tapping bolts into quite long holes, sometimes I find a little application of grease, white grease or whatever, can sometimes make those a little bit smoother, just because sometimes they get quite tight when you start putting them in. But that's your assembly. Take care, everything at this stage now should be solid but loose, so that gear should spin quite clearly, and these three on the outside should spin freely on there. So you don't want them kind of meshed up, you want to just tighten it up to the point where this can still spin quite freely. Okay, and then obviously what you've got is your driving your collet, and that's how that kind of goes in there. So what I'll do now is I just want to talk about, put that part to one side, and then what I'll do is I'll pull in the motor. So the next part of the assembly is to take the motor, and this is just obviously not particularly detailed version of that motor, but you'll hopefully have the real thing. The planetary gearbox prints out, again, similar thing with the outer layers. You want as solid as you can, and this has got 3 holes, 1, 2, 3, where this gearbox literally bolts to this motor. You do get the screws for these generally with the motor. If you haven't got them, I think they're M5s or M6s, but again, you can just check on the holes when you get there. In fact, I can probably have a look to see what size I made these, which made them something. So yeah, 5.4mm. So I think they're M5s. So M5 ones will bolt this in nice and solid. And then once you've done that, your next thing to do is to put your collet assembly on. So you remember the gear and the collet that you did before, which is there. So you just push that one in, and then you'll see on one side of the gearbox is a hole, and through that hole that will give you access to the grub screws, or the screws that hold that collet on. I'd also recommend using something like Loctite to make sure that's solid. You want this to be really solid because this is the main engine of your whole thing. So a bit of Loctite to hold it on, lots of screws in there, that's great. And then all you really do is all along this inside of this gear, lots and lots of lithium white grease, so it's well greased. And then you can take the whole of the assembly that you just created and put it on the outside. So, whoops, we didn't want to see that gear, did we? You can put it on the outside, and then literally what you can do is bolt the assembly together, which again is taking these, which you've got about 50mm. So again, M350 countersunk bolts will go through there, and what they'll do is they'll self-tap into the inside of these, inside of this shaft here. So 50mm, 1, 2, 3, 4. That will give you a really solid planetary gearbox, and it gives you about a 4-to-1 reduction. So every time the motor spins 4 times, this outer motor will spin once, which gives us the power that we need for the actual drive unit. So that's your planetary gearbox. Let's have a look at what that meshes onto. So that angled gear meshes onto this, which is our core drive gear for the main drive. And these are the wheels on the main drive. So I'll just talk you through these kind of wheels, if you like. So they're made up of a few parts, and I'll just hide a few of these so you can kind of see what parts they're made up of. And some of the bearings and some of the spacers and whatnot. So yeah, so what you've got here is you've got these little hubs that sit in the middle. So these hubs go right the way through to there, and as you can see, I'll just hide those spacers there in that one. You can see on the hubs that that's the wheel. There we go. Yep. So you can see on the hubs that what you've got is a number of screws that go right the way through. Similar to some of the other printed shafts, what I tend to do is run the holes right the way through. So what you can do is run quite long bolts through there, so that it also strengthens the middle piece. This is printed with this being the flat on the bed, so it means your layers are going this way. So it does mean that it is actually quite a strong print anyway, and because it's kind of tucked into the gears, it's got additional strength. So take a few bolts. I'll take 1, 2, 3, 4, 5, 6, 7, 6 bolts, and as I said, the hole on these goes pretty much through to that bit, so you've got a full 81mm. So what I did is I used 35mm from each side. So I took M3 times 35, which was the countersunk bolts, and I put 1, 2, 3, 4, 5, 6 on one side, and then similar, what I did is put the second wheel on this one. Now on this one, you've got 6 bolts that attaches it to the hub, and then you've got these other ones here, which effectively attach the gear to this outer plate. So and again, they'll take M320s, so 20mm on the outside, 35mm on the inside, and these are all M3s, and you tighten it up to make this really kind of quite solid assembly. Okay, now the way that the build works is you can build both sets of wheels. I'll just cover off the back wheels while we've got this up. So the back wheels is a little simpler than the front wheels in that you've just got the centre hub, and then you've just got the 6 either side bolts, 35mm bolts, which will hold that together. One thing to watch for when you're assembling these is these little faces here. This face and this face, this face and this face should be perfectly level, so they have to line up, because that's what the track runs on. It is possible to get these at the wrong set of 6 holes, because they're all evenly spaced, and what will happen is these top ones won't line up. So make sure that on both sets of wheels that those line up. Once you've done that, then you can take some bearings. The bearings that I'm using on here are these bearings here, so they are 25mm in the centre, 35mm on the outside, and 7mm deep. So the same ones as what we just talked about that sit inside the planetary gearbox. And what I've also added to these is a little spacer in there as well, because you've got these bolted in. What I didn't want is the bearing to rub against that, so there's these little thin spacers that fit in there, and they'll fit on the inside of here as well, before you actually sort of put all of the bearings in there. So once you've fitted all your spacings, fit all your bearings, and you do that on both sides of the wheels, and then effectively that's your wheel assembly complete. So once you've done your wheel assembly, the final part then is the frame. So let's have a quick look at the frame. Okay, we'll turn it up the right way. Now, what I'm going to do is I'm using 20x20 extrusion, which is the main frame that goes underneath the ALT. So we'll just remove that for the time being, because I just want to look at how the frame actually goes together. So the frames, it's an interesting little build. And let me just go into cross section, and I'll show you why I mean it's interesting. So what actually happens is where the bearing is, the I'm noticing this side on the front side is probably the better place to see it. So where the bearing fits in, which is here, this is the bearing here. The frame actually goes into the bearing, so the bearing, the frame's on the outside, and this sits on the inside of the bearing to make the wheels spin freely. So if we just take that back again, so we can see the whole thing. Cancel that. Yeah, so if I just hide the wheels for the time being and have a look at the frame. So when you print the frame, it comes up with this. This centre bit is where the actual bearing sits. This keeps a gap so it doesn't rub, and then it goes up against these frames. Now the frames are quite simple in the way that they're assembled. You've got two main pieces. The two main pieces have got this frame that sits in the middle here, this little L frame. This bolts in through 6 little bolts, 1, 2, 3, 4, 5, 6. Same on this side. Again, the bolts on there are about 18mm deep, so you can run 15s or 20s in there. There's still plenty of space. So M320 countersunk bolts, 6 either side, would hold those in. And then similar on the bottom ones, you can put some your bolts in there to hold. So that holds them. This becomes a really big solid frame. And then once you've got this frame complete, so 1, 2, 3, 4, and this piece here, what you can do then is you can and obviously so once you've got the frame and the wheels in place, what you can do then is drop the motor and this frame in from the top, and you can bolt this in. Now the bolts for the motor, and again these bolts here, 3mm bolts, but what they're using is they're using square nuts on the inside that drop into these little inserts. So you'll need 6 on that side, 6 on that side, so you'll need 12 per motor, 12 per drive. And then what happens is the main M3 bolts actually then kind of go through here. So, and again, if we look at the depth, a 20mm bolt will easily go through there and hold that. So M320s, countersunks, 6 with the nuts, and that will hold that frame in really quite solidly. And then the final piece that goes on top of that is this frame. Now this frame's a little bit more fiddly. You notice you've got a hole here. So this is for the cable for the drive system. So the cable for the motor comes up through here. There's also, I don't know if you can see that, but there's a little loop that lets you put a cable tie in there, so you can tie that cable in. Similar to the other ones, it's got this is held in place with M3 square nuts. The reason I use square nuts is sometimes these parts are ones that you may need to assemble and disassemble. Now you'll need longish ones, so again 35mm bolts for these 4 holes here that hold this frame in place. And then these, what you kind of do is push the screw into here, drop the screw down into that square nut, and again M320s will cover it, or M315s, and then you've got a hole at the top that lets you put a screwdriver or an Allen key through to kind of get that down. So that's where you are to get the frame in place. So bolt there, bolt there, bolt, 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 bolt. And what you end up with is quite a solid frame. And then you've got your extrusion. So what we're using is 2020 extrusion and little T-nuts. And the way this is held in is you put your little T-nuts into this particular hole here. You slide it along, and then you can get a couple of T-nut screws in there to hold that bar in place solidly on those 2 parts. And that effectively gives you the full assembly of your drive unit for these. They are a solid drive unit. The bits, again, as you know, I keep stressing, is particularly this gear and this gear. Make sure that you've got lots of outer layers, outer walls on there. People talk about infill as being the strengthener. Actually, it's the outer walls that really gives lots of gears and things like that its strengths. and also the adherence between layers, which, you know, again, you can try more exotic materials, but I find PETG works perfectly well for this. So once you've assembled one motor, it's literally doing exactly the same thing on the other side, so that you end up with the full drive frame. Now the 20mm extrusion, I'll just give you the measurements on that so you can kind of see what that is. So the measurements on the 20mm extrusion across that distance is 794mm, so 795mm. So I think I got two 1 meter lengths, and then I just trimmed them down to the size that I actually needed for the ALT drive. And that's pretty much it for the main drive. What I'll just cover off then is obviously the tracks. This is as you can imagine, a lot of printing. You've got I'm not sure how many tracks we've got on there. Yeah, you've got 35 tracks, I think. I think it's 35 tracks you've got per side. And the way these tracks work, let me have a look. So these printing flex, and what you've got then is you've got a hole on the side here. So if you look through the length of these tracks, which I'm just inspecting again, so these are 110mm. So I ended up getting, I think, 100mm rods. Again, you can get these. I got mine from eBay. They are 2.8 in diameter. So I think I had 100mm by 2mm rods that held these in. And what I did actually, that diameter, I know that's 2.8. Yeah, it's diameter 2.6. So 2mm by 100mm rods, helicopter RC rods. And what they do is they just push through, and literally you print a load of these and you build one after the other to create the track system. And then when you've got down to you've completed and made the full track, you wrap it around and you just put the last rod through. What you've got on this side here then is a little area that you can put a self-tapping screw in there just to hold it in place. So again, same as we've done with the other ones, which is M3s, M3 by 5s or M3s by 5mm will just go in there, tighten up and self-tap and hold those in place. The reality is they're quite snug actually anyway, and generally don't need it, but it's belt and braces sometimes, I think, in these kind of things. And that's pretty much the drive assembly for the ALT. And then obviously the way this assembles is you have it bolts through the skirt, so you can see the printed skirt's got holes for the extrusion. You have 4 holes there, 1, 2, 3, 4 there for exactly the same as we hold it onto here. You get the T-piece and little T-piece that drops into the extrusion. You put a bolt through there and you tighten it up, and then it holds the skirting really quite nice and snug. And what it means weight distribution wise is all the weight of the droid is on this plate here, and this weight distribution is directly on onto this bar here, which then sits onto this bar here. So it's actually a really solid way of building up the ALT drive. So there we go, another quick video which just talks through the ALT drive. And then obviously as you start to build them up, you literally drop the body and the legs on top of that. And as you can see, what you've got to watch when you start to assemble it, just watch all the clearances. These outer things don't move anyway, they're part of the frame, so as long as everything fits together, it's all okay. And they're pretty good, solid, reliable drives. Your power cables come where we showed before, but will come out through here, so you can run all of your batteries and your RC equipment on the inside. And that's pretty much the 1-to-1 full-scale ALT drive, track drive assembly. And hopefully, again, that was useful.